I hope you like monitor repair videos because that's what this episode is all about. I got a bunch of K7000 monitors out in the garage that I'm trying to get dialed in. I'm trying to get working, perfectly. So that's what we're going to focus on in this episode. And yeah, I know the arcade is off. We got a really bad thunderstorm going on right now, and I don't want to turn everything on and risk any kind of power surges or anything. But anyway, so I got a 19-inch K7000 that's been giving me some grief for a while. I think I've finally figured out how to get it completely dialed in and locked in really nice. I've also got another 19-inch K7000 that's really intended for my buddy and channel member, Jerry Voluptuous. Awesome guy, I really want to hook him up with something nice here. That monitor is coming out of my Defender cabinet, believe it or not, and I'm pulling it out because K7000 doesn't belong in a Defender. And then I got a couple more monitors we're going to try to sort out, push our luck, see if everything is working properly. So yeah, that's basically what we're going to be working on in this video. Here's a little sort of tour in progress of the new lineup down here in the basement in the new room. But yeah, if all of that sounds like fun, why don't we start by heading outside and washing a couple of these filthy monitors. Let's go!
Overtime!
Okay, these are the two K7000 chassis that I'm working on. These are the two that I just washed. Off camera, I used my air compressor with very low pressure to knock off all of the loose water that was sort of pooling on the chassis, and I had them under this big industrial fan for about 3 days, like 2.5, 3 days. I did take the one that was mounted in that monitor out of the frame. And so I actually already went ahead and recapped the chassis on the left, so that one has a cap kit installed. This is the one from the Sly Spy that we're going to reinstall, and this is the other one that's going to go to Jerry Voluptuous. Again, this came out of my Defender cabinet, believe it or not, with a replacement monitor in there. And we are ready to go ahead and test this chassis and then also work on this one, put a cap kit in and figure out whatever else it might need, if anything. But before I do that, I wanted to just point out a couple of differences between these two chassis. Even just from a distance, they look quite different, but they're really not. These are actually both K7000 chassis, 19-inch K7000 chassis PCBs. And they're even both K7600 sub models within that K7000 product line. The one on the left here is actually a 19K7611 manufactured in February of 1989, and the one on the right is a 19K7689 manufactured in April of 1992. So beyond the sort of cosmetic differences, there are a couple of things to sort of point out. So this chassis PCB is marked P447, and this is marked P447B, so a bit of a variance from it. I think they're relatively compatible. I think they're basically the same, but there are some component level differences. This has the older white knob flyback that actually not the best in the world. This has a later black knob PCB, and I looked at the solder marks on the bottom side. This is the original flyback. It hasn't been replaced. Looking at some of the other differences here, this is obviously like a pinkish, PCB with black writing on it. This is more of a light beige color, and it actually has the circuits sort of, or the traces silk screened in green onto it. Some other differences to point out. The IC1, which is the vertical deflection circuit, is a slightly different form factor. The older one has sort of 2 screws mounting it to this heatsink, and this one has a single screw that's mounting it, so a little bit of a difference there. Both of them have remote boards. The older one has actually wires soldered directly to the PCB that goes to this connector to plug into a remote board, while this has connectors right here on the chassis PCB itself to unplug the harness for the remote board. What else is a little bit different? On the neck board, we have slightly different styles of sockets. They both fit the same size, the same pinout of socket, but a different sort of style. And then also this C204 capacitor is a little bit different. So the original one here, which is the one capacitor right here, was actually originally a ceramic capacitor, and I replaced it with an electrolytic, versus it is an electrolytic on this version of the neck board. So there's probably some other small differences too, but again, I think they're essentially compatible, and you know, same cap kit, same flyback and everything like that. So if we come over here to the cabinet, and we'll get on the tripod, and we'll go ahead and install that chassis back into this monitor. Okay, so for this one, I actually, left the monitor and the frame intact, so I only washed the chassis. I didn't wash the whole thing, so this thing is still kind of dirty, but that's okay. So we'll come in with our chassis PCB, and we'll start to kind of get things lined up. And I want to make sure that these wires are not tangled or anything. And there's a couple connections that I want to make before the whole thing is installed all the way. The first is the yoke wires, which go in like this, and I double checked with the photo that I took before uninstalling it, just to make sure I have everything in the right spot where it's supposed to be. You do not want to install the yoke connectors incorrectly. Like, you can flip the colors, but not you don't want to plug in the vertical winding where the horizontal winding goes. So that's good. And then we have the Diodes circuit, plugs in right here. And doing it when it's sort of hovering above the frame is a little bit better. It's easier to sort of reach in there. So we'll slide it in all the way here. And then there's just a couple of screws or bolts that sort of hold it in place. There's one. And there's the other right here. And we'll screw those down real quick. Okay. All right. And we can start to make our other connections here. So first we'll do the DAG wire, which I cut that wire and installed a quick connect right there. And actually, let me loop the the harness of the remote board through that, just so it doesn't get tangled. And now you can imagine why they switched to a connectors, so that this wire isn't just flopping around everywhere. Let's see, we can plug in our neck board ever so gently, and I need to reinstall the cardboard piece that was the protector. We'll come in with our video cables, and they go in like this. There we go. And I like I said, when I did the cap kit, installed the cap kit on this chassis, I also reflowed the video input header, and I reflowed the yoke connectors, because those have a tendency of running into some issues. Just plugging in the harness for the remote board, and we can go and connect our anode cup. Get these rabbit ears to sort of grab into the dimple in the tube. All right, there we go, nice and secure. If that's not secure, it will arc, so you want to make sure that's seated nice and well in there, and not going to fall off. So that's good, and we can make our power connection, and just going to double check. I think that's everything. The frame is grounded. Everything looks good. So I'm going to plug in the cabinet, and we can fire this thing up. So I'll keep you looking at the chassis just in case something explodes. But here we go. It's plugged in, and I am throwing the power switch. If I can find it. 3, 2, 1. All right. No caps have exploded. That is a good sign. Come around. Awesome, we do have an image. Let me take you around over here. A little spinneroonie, and look at that. That looks much nicer. Let me change the refresh rate on the camera here. All right, I think that looks pretty good. Let me just make some minor adjustments to the height and geometry. Okay, I think I got it dialed in pretty well with the, thanks to the help of my Delusionals Arcade monitor adjustment mirror. You know, it's still a little bit wider than I want it to be. You saw by the quotes off, but it's not doing that sort of distortion at the bottom. So I think we're pretty good. I tried, you know, adjusting the width. Again, it's still just a tiny, like part of the end of Golden Gun is getting cut off. I might experiment with a width cap kit. I do have that. You know, you can actually change out, I think it's C38, some of the caps, or one of the caps on the chassis to adjust the width if the width coil isn't doing it. The width coil is adjusting the width of the image, but it's still, even at its narrowest, it's a little bit too wide. So I might do that, especially while I'm working on the cap kit for the other K7000. But other than that, this has been a success so far. Okay, I pulled the chassis back out of the Sly Spy, and yeah, I have decided to experiment a bit with the monitor width cap kit from arcadepartsandrepair.com. I figure I have it, I might as well use it. So, and yeah, I'm using my AV cart as my workbench right now, just because all of my workbenches and even my folding table are completely covered with parts. I picked up a bunch of monitors over the past couple of weeks. There's like 6 monitors on the folding table right now, so we're making do with what we have. So basically the idea here is, and you know, this monitor with cap kit works on a couple of different monitors, and essentially the idea is, if you've got an issue where you can't get the width of the image to be what you want, even with the width coil, which is right here, you can see it's kind of maxed out with the ferrite slug is all the way up at the top. With most monitors, there is a cap that you can swap out and use that to control the width of the monitor. And like I said, every monitor is a little bit different, but on the K7000, it is a capacitor at C78. And this is like, I always think of these as like chiclets. This is I guess it's a metallized polypropylene film capacitor, which is what we have right here. It's sort of not nearly as shiny as the replacements. And the cap kit gives you a bunch of different values. You can see all of them here, but there's only one on the monitor, one on the chassis. And basically you swap them out, you know, one at a time until you've got kind of the range that you're looking for. There's a bunch of different values here, and the higher you go, the narrower it gets. So we want to go higher than the current, and I believe the original value is 0.33 microfarad. We want to go up. There's a bunch of different values here, and I think, you know, what I want to do, because Peter in this kit gives you 3 different ones that are 0.47. That's what I'm going to do, and this is also form factor wise the best match. It's a higher end, higher voltage rating of 630 volts. So this one right here, which is a 0.47 microfarad 630 volt capacitor, is the one that we're going to install. So obviously we need to remove the original, which should be this right here. So let me grab some flux. Actually, it's right behind me, and put a little flux on, and we will add a little bit of fresh solder. And I'm running low on this reel that I've had for a couple of years, and we'll add some fresh solder just to help melt the old solder. Okay. And then I'm going to use my Vampire Tools solder sucker, which I've had for a while, but lately I've really enjoyed using it. All right, melt that solder, suck it. And sometimes it's a pain to eject the old solder. All right, maybe 1 or 2 more passes here. That it looks pretty close. Get the other side. Often there's a little bunch of old solder that comes out. It's got to come out somehow. Okay. Now let's see, is it loose yet? Yeah, it's loose. There we go, came right out. See, look at that, C38. Yeah, this looks a little toasty. Oh, it says right here, 33.4J200. So I think this means it's a 0.33 microfarad, 200 volt cap right there. So we've got our new one. Let me actually clean up these vias just a little bit with my solder wick. Just get this a little bit more cleaned up. Okay, that looks pretty good. There's a tiny little solder ball that I want to grab before it causes an issue. There we go. So we've got our new one. Slide this right in here. And sometimes you got to experiment with a couple different, trial and error. Try a few different ones, but hopefully this will do the trick. And I think the old one was raised a little bit. Let me look at the other K7000 chassis I have right here. Yeah, it's just a little bit. And what I'm going to do is I'll make a little divot here. Just to kind of help me guide this in. So that should be good. Just bent the legs a little bit on top so that there's something to kind of line it up. Keep it from sliding all the way down. Come on. All right. And now we'll just solder these new legs in place. Here we go. These are some pretty big pads, so taking a bit of heat. All right. Actually, I want a bit more solder. These are rather large pads, so okay. Let's see how that looks. That looks pretty good. Looks good over here. Of course, we're gonna double check continuity with our multimeter. I know, I probably, it's actually very rare when I screw up a solder joint, but better to be safe than sorry. Good. Okay. Cool, so let me trim these legs and I'll go ahead and try to clean up some of this flux a little bit. And this looks terrible. There's a lot of cooked old flux on this, but we'll clean this up. We'll throw it in the cabinet, and hopefully that fixes our width issue. Okay, I've got the chassis with the new width cap installed back into the monitor, back into the cabinet. So here we go. We're gonna throw it on, give it a test, and hopefully it works. 3, 2, 1. All right, nothing's exploded. And let's see what comes up on the screen. Okay, that is not good. So that would be vertical collapse. How did I manage to do that? All right, let me go check the yoke connections and see if that has something to do with it. All right, good news. I think we're good. All the scores are visible. The left flagpole is visible. You know, all it was, oh yeah, now the quotes are all visible right there. So all it was, I didn't plug in the yoke the right way. The vertical connectors, one was shifted off. So, you know, there's 4 pins that make up the yoke connection, 2 for vertical, 2 for horizontal. This one, the connector's been broken apart and flipped to sort of invert the image. And yeah, I was off by 1 where it was just not connected. So that's why we had vertical collapse. So on a horizontal monitor, obviously the, you know, up and down is vertical and left and right is horizontal. And when, you know, we have a collapse issue, that means one of the axes has collapsed, right? And you have no deflection on one of those axes. And so on a horizontal monitor, when everything is flat left and right, that means you have vertical collapse because the vertical axis has collapsed. If you only had a vertical line, that would mean you have horizontal collapse because, you know, the horizontal deflection is collapsed. You don't have any horizontal deflection on your yoke. People get confused by that all of the time. So just remember, a horizontal line actually means vertical collapse, and a vertical line means horizontal collapse. Unless you have a vertical oriented monitor. And remember, the monitor is always designed for, or the tube is always designed for a horizontal installation. And so when the monitor is turned for a vertical installation, you know, a horizontal line on a vertical monitor is horizontal collapse. It gets confusing, I know. Maybe I should make some sort of t-shirt or something to help people understand this and remember it. Just in time for back to school shopping, we've got a brand new product launch available exclusively in the Overtime Arcade official merchandise shop. Don't ever be embarrassed again by not knowing the difference between vertical collapse and horizontal collapse. Plus, help educate everyone around you about this very important topic. This stylish and informative design comes in both a men's t-shirt as well as a men's tall t-shirt in a variety of colors and sizes up to 6XL. Featuring examples of both vertical collapse and horizontal collapse on both vertically and horizontally oriented monitors, you'll be the envy of all your CRT monitor enthusiast friends. To celebrate this new product launch, everything in the Overtime Arcade merchandise shop is currently 20% off. That's right, 20% off everything in the Overtime Arcade merchandise shop through Monday, August 5th, 2024. With this limited time deal, our new t-shirt can be yours for less than $16. So click the link down below to grab some top quality Overtime Arcade merchandise for yourself. Now, back to our program. Anyway, I think this monitor is finally totally done. So we can come around, whoa, to the back of the cabinet and do our final finishing touch. Come in like this. And let me adjust the refresh rate here. Okay, like I said, we can come in here with our finishing touch, which is the sticker that comes in all of Peter's kits, just to memorialize, especially because this, you know, this game is leaving my possession, possibly forever. We want anyone in the future to know that it was I, Charlie, who worked on this monitor. So hopefully, fingers crossed, 2 fingers crossed, we are finally done with this monitor. Okay, I'm ready to move on to installing a cap kit on the next K7000. Specifically, this is the 19K7689 with the P447B main chassis PCB. I feel like I've done cap kits on a million K7000s in the past. I feel like I've done it a million times on this channel. So I'm going to fly through this. A cap kit on a K7000 is really easy. Probably one of the easiest that I've ever done. You know, there's only about, I think, 21 caps on the whole thing. They're all relatively accessible. There's 1 or 2 kind of tucked in here behind the flyback, but you know, if you've got needle nose pliers, you can reach them pretty easily. No need to, you know, take everything apart. So I'm gonna go ahead and do this. I'll let you know if anything weird or interesting pops up, but it should be pretty straightforward. And we'll see if it works. You know, this, I guess I would consider this an untested chassis, but it looks like it's in relatively good shape. So yeah, let me go ahead and get started, and I'll let you know if anything weird happens. Okay, that cap kit is complete, and I reinstalled the chassis back into this monitor. Again, this is a 19K7689. This K7000 came to me in my Defender cab. Now, obviously, Defender didn't come with a K7000 originally, so this is the one that's going to go to Jerry, and I'll put I got some K4600s. I'll put one in here. So I think we are ready to go for a test. Everything is plugged back in and ready to go, and I got my TPG connected, the Crafty Mech test pattern generator. I've got my compact portable isolation transformer power supply plugged in, so we should be good. I've got the camera positioned to hopefully see something come up on the screen and nothing explode or catch fire in the back, but you never know. So let me turn on the TPG, and we will throw the switch for the power in 3, 2, 1. I hear the HV coming on. All right, we got something on the screen. That's good news. Come around here and let you see what that looks like from the front. I'll go ahead and adjust the refresh rate so it looks a little bit better for you. All right, so we got an image. We have to make some adjustments here. Let's see. Let me start off with the focus. See what's a good way for me to adjust this while taking a look. I think the colors are all out of whack here. Maybe this flyback is bad. Yeah, that's Okay, that actually looks pretty good. The contrast and the black level pots on the remote board were really cranked, so we are in much better shape now. Let's just see if we can dial in this focus ever so slightly. All right. The focus really prefers to be cranked all the way, so I'm not sure what to make of that just yet. Let's see if we can adjust this just a little bit more. Okay, I think that's all right. The only thing I don't love about this is I've got the focus knob cranked all the way to one end to get it locked into this image, but let's check out some of the other test patterns here. That looks pretty good. Look at that. That's a pretty good image. All the colors are there, nice and present. We could probably make the black level a little bit darker. Let's see. There's my adjustment tool. It's not bad right there. Let's keep stepping through. There's a little bit of burn. It's pretty moderate though. Okay. Yeah, I'd say that's pretty good. So yeah, let me actually turn this off and check the B plus real quick. Okay, now we're set up to test the B plus voltage with my multimeter. I've got the black lead connected to the chassis frame, and I've got the red lead to the blue wire coming off of this big ceramic resistor. And what we're looking for is around 123 volts DC. So here we go. And yeah, I'd say we're pretty close. 124, let me put it on a checkerboard or a crosshatch pattern. And yeah, I mean, it's a touch high, but no problem at all. So let me do just a little bit of research. You know, I've got plenty of reproduction K7000 flybacks, and I'm not against putting one in, but let me do a little bit of research and see if this is something that can be fixed by replacing the flyback. Okay, I checked in with Mike and talked to him a little bit, and he thinks it is probably the flyback. He says that if you're not able to really dial in the crispness of the picture between sort of halfway and 3/4 of the way through the adjustment range of the focus knob, he says that means it probably is the flyback. He says, you know, it could be the tube, it could be the socket, but odds are it's the flyback. So we're going to go ahead and replace that. So really appreciate being able to reach out to Mike like that, who is definitely not an amateur when it comes to repairing arcade monitors. And I know I've done this a bunch of times on camera before, replacing flybacks, including on a K7000, but people always complain when I don't show the entire process on camera, so we'll go ahead and do that. We have these 10 pins on the flyback here. I think those are the only things that hold it in place on a K7000, plus these 3 sort of plastic clips, of course. So I'm just going to come in here and put a little bit of flux on the old solder. And I'm using my flux pen here, my Kester flux pen, which I like because it doesn't just run everywhere and get everywhere. And I always put all the tools that I use and all the parts and everything in all of my videos. I always provide links to them in the video description down below. People never see that, and they always ask me what tool you use and where can I get it. And I have to refer them to the video description all the time. And I forgot to lock the wheels on my AV cart that I've pressed into service as a workbench. And here again, I'm just adding fresh solder to all the old solder. Makes it easier for the old solder to melt and then be removed. So this should be good. And yeah, I want to get this monitor really nice for Jerry. He's been a huge supporter of me and my channel, and I want him to have a great monitor for his purposes. All right, now I'm going to come in with my Hakko desoldering tool and remove as much of the solder as I can. You know, I've been on Team Solder Wick lately, but for certain applications, the desoldering tool really is the boss. Until it jams up and loses suction. Yeah, that should be pretty good. And we'll flip it over, and there's actually a bracket that holds it in place. Find my screwdriver right here. We'll remove this screw, and hopefully, with other than these little clips are probably the only thing holding it in place now. Okay, it required a little bit of coaxing, but I was able to get the original flyback out of there. You know, at first I thought I was hung up on some with some old solder that wasn't letting go. Turns out it was the bracket that was holding it in place. Yeah, this also acts as a heat sink for this transistor. And yeah, that's my my fault for trying to save a step of not removing it and hoping I could wiggle out the flyback, which I think I've been able to do in the past with some K7000s, but Obviously not in this case. So, and then I, disconnected the screen pot from, which is just a single plug. I don't know if this is technically Molex, but I use a little really thin flathead screwdriver to, extract the pin from the connector, because we'll want to reuse the connector. And I think I've got the exact right replacement pin here. So that's what we're going to use on the new Flyback. And this is I desoldered the focus wire from the socket, and this piece pries off, and we'll have to sort of pre-fish it onto the replacement. So that's looking pretty good. So let's go ahead and open this new Flyback. All right. And let's see what we're working with here. Okay. One of the little clips already broke off, but that's fine. I usually end up cutting those off anyway because they, are rare for them to perfectly align. So we'll take a look and see how that's going to line up. And we've got both of the wires, well, the big fat anode cup wire right there. That's a little bit of excess potting or epoxy. So that's good. Maybe we'll replace that little metal disc in there. But you see we've got two wires coming off of the Flyback now, in addition to the big fat anode wire. And the colors change, and one thing to remember is, the fatter wire is the focus wire that goes to the neck board, or to the socket on the neck board, and the thinner wire is the screen wire that goes to the post on the neck board. And you can't go by color, and you can't even go by position, because on the original the screen wire comes from the bottom of the Flyback and the focus wire comes from the top. In this case they both come from the bottom. So I'm going to go ahead and pre-fish this the socket cover back on. So we'll do that. And I bumped it out of the wire holder already. So yeah, let's go ahead and install this thing. All right, another thing to point out is the form factor is ever so slightly different. You'll see that the reproduction Flyback is a bit shorter, and it doesn't have the post on top to be screwed onto the bracket, which is fine, but cool. And we can, let's see, why don't I actually crimp on, while we've got the Flyback out and loose, I'll crimp on a pin to put this connector on. So we'll take one of these, and this is a 1.55 millimeter female, I think this is technically an amp pin, not a Molex. Let's see, where's my cutters? Right here. I can probably actually just bend this off of the strip. Yeah, there we go. Put this off to the side. Hopefully it doesn't fly away, because I have my fan going. And let's see, we want the thinner wire, which is right here. Just sort of see if we need to trim this at all. It's probably, actually we can stand to trim this a little bit. Trim the excess length of wire. All right, that looks good. And I don't have my ratchet and crimpers out. And I want to be careful here not to mangle this thing, because that would not be good. All right. All right, now I've got it in there and should be able to crimp it. And we'll take a look, and yeah, that looks pretty good. So we can position this to go on like that. And there we go. So that connector is reattached, so that's good. Get this out of the way. And next thing, why don't we, all right. solder the actual flyback onto the board. And often you have to bend the pins a little bit to get them to perfectly line up with the holes on the board, but we'll see what we need to do here. Oh, this actually looks like it's perfect right out of the box. All right, look at that. And this was great. So these were perfectly aligned. They went right in. Even 2 of the 3 plastic clips went right through the holes. And the third, like, I accidentally busted it off as I was taking this out. But now we can go in and straight away solder these the pins onto the chassis. So that looks good, and now I can untangle these wires, and we will solder the, whoops, it keeps wanting to fall off. Move this stuff out of the way. We'll solder the focus wire onto the socket, and there's a little loop in here that you can sort of see. This little metal tab is what we've soldered onto, and it's kind of a pain to avoid melting the thin plastic that's around it. So what I'm going to do is I'll find my heel nose pliers, and just to ensure a nice connection, we'll put a little hook into the wire here. And this is going to go in like so. Looks like it goes straight in. And we can go like this. Hook it in. And we'll pinch it closed just a little bit. And now we can solder this connection. All right, that looks nice and secure. And so we can slide the cover piece right on down here. All right. This just clips back on. Okay, the gimbal on the camera gave up on me again, but we got the focus wire soldered onto the socket, and we clipped the cover back on, and you know, the flyback is soldered onto the chassis PCB. We soldered the this IC back onto the board that's mounted on this bracket slash heatsink, so that's all good to go. And we plugged the screen wire back onto the post on the neck PCB. So I think with that, we are good to go. I'm going to go ahead and clean up some of the flux on the solder side of the chassis PCB, and then we'll throw this thing back into the monitor, give it another test, and hopefully we've got better focus control now. Okay, with the new flyback installed, I've got the chassis plugged back into the monitor. The monitor is completely reassembled. 2 last things that I did. I put a little loop, like a knot, into the anode wire, just because all of the original flybacks that I always see always have that sort of loop. I don't know if it does anything. I don't know if it's maybe just to prevent you know, the wire from getting caught up on the yoke or something, or if it serves an electrical purpose. I don't know. Do you do that? Do you know why people put a loop on the anode wire? The other thing, you know, the original anode cup had a little metal disc that sort of went between the rabbit ears and the prongs and the suction cup, and I transplanted it on, you know, from the old flyback onto the new one because the new one didn't have it. Again, I don't really know if it does anything, but makes me feel a little bit better. So I think we're ready to go. So I will turn on my Crafty Mech TPG. I will turn on my multimeter, which is hooked up to test a B+ voltage. And we'll throw the switch on the power supply. 3, 2, 1. Okay, pretty good. 123.6. It's supposed to be 123. And no image on the screen just yet. It is bright in here. So let's come around and see if maybe I need to adjust the brightness. see if that does anything. Yeah, there we go. There's an image. And, all right. So that's maxed out focus, which makes it out of focus. And right about there, at the 3/4 mark. Looks pretty good. Let's step through. We're still at 123.4. Stepping through the TPG patterns, checkerboard. There's our nice color bars. How's that looking? We can adjust. I can adjust the black level a little bit maybe. It's kind of bright in here right now. But there's our crosshatch. I think that looks pretty good. So I'm going to adjust the brightness levels a little bit and the all that. I'm going to do that when it's darker in here. Like you can see how much glare there is and reflection and everything. So I'm going to do that when the garage is nice and dark, when the sun goes down. It's just after work right now, and we'll get all that dialed in. And then I'm going to let this run for several hours while I'm working on other stuff in the garage, just to make sure everything is good. But I think we've got a pretty good monitor here. I don't know if it showed up on camera. There is some very mild burn on this tube, and I think it's from super high impact, Williams football game. But it's barely noticeable. So I think it'll be good. So yeah, Jerry Voluptuous. I think we've got a nice night. Oh, and look, hold on. There we go. The refresh rate is better now. And again, it's very bright in here. This is a nice, vibrant image. We'll get it all dialed in. But Jerry, I think you've got a good 19-inch monitor heading your way. All right, because things went so smoothly with the first two monitors, I figured I would tempt fate, push my luck, and so here is a third K7000 monitor that we're going to try our hand at. Now this one is a bit different. If you can't tell from the perspective, it is much larger. This is a 25-inch K7000. In fact, if we look at the model number right here, this is a, where is it right there? 25K7191. So a 25-inch K7100, K7000 series. And yeah, nice big screen right here. This actually came out of my weird Golden Tee cabinet. If you remember me showing that from, I don't know, over a year ago. That's been sitting in the back of the garage, with nothing doing. I got that cabinet for free. We tested the PCB and the PCB wasn't working. I've since obtained a working Golden Tee 2K, Golden Tee 2000 PCB. This is the monitor that was in the cabinet. I don't think it's original for a couple of reasons. First of all, because this is a K7000, it requires an isolation transformer to operate. As you can see from the warning label right there, isolation transformer must be used. This cabinet, however, does not have an isolation transformer inside of it. The Golden Tee that I pulled this out of doesn't have an ISO. So I'm guessing this was a replacement monitor put in there at some point. I'm hoping they didn't try to run it without an isolation transformer, because that can really cause some damage, blow diodes, maybe bridge rectifiers, different things like that. And yeah, so I don't think I've ever tried powering up this monitor. I may have. Maybe I should have gone back and watched that Golden Tee pickup video. But I figured, why not, again, roll the dice here and see if we can get something going. So I've got it all plugged in, got it connected to my compact portable isolation transformer power supply. So this thing will be tested on an ISO. I've got my Crafty Mech test pattern generator plugged in to provide an image. And I have my multimeter set up and connected to test and measure the B+ voltage. So I think we're ready for an initial power up and see what we've got going on here. With the B+, we are going to be looking for 130 volts on the multimeter, not 123. So this is a 25-inch K7000, and on the 25-inch, you want 130 volts versus the 19-inch. You want 123. There's different voltage regulators that control that. So with that, why don't we fire it up? We'll turn on the multimeter, set it to DC volts, turn on the light, maybe to make that a little bit easier to read. I will turn on the Crafty Mech TPG test pattern generator, and we will throw the switch on the isolation transformer in 3, 2, 1. That is a doornail. Yeah. 0 volts, nothing going on. I am not at all surprised. I mean, nothing smoking, nothing on fire. So, yeah, everything is plugged in, right? I had to put a crimped new connector, power connector onto the, or new Molex connector and new pins onto the power wires. But, all right, well, let me do this. Let me pull the chassis out and I'll start poking around, checking fuses, looking at components, and then we'll come back on camera and do some more, diagnostic troubleshooting together. Okay, I pulled the chassis out of the monitor and started looking around. And here's what I found. I kind of followed the classic flow chart. And the first thing to do is to check the fuse F1, and you'll see right here that it's blown. So no continuity across that fuse. And then, I checked the hot, I checked the voltage regulator. Those both looked okay. I actually even pulled the hot out of circuit, tested it out of circuit, and everything seemed good. So the next thing you want to check in that case are the rectifier diodes. So the 4 diodes, D19, 20, 21, and 22, and I have them sort of arranged right here. And blowing those can be consistent with running the monitor without an isolation transformer, which is my suspicion based on what I've seen in the cabinet. So if we put the multimeter on diode test, we can come and check these, and we see right off the bat D19 is good. I'll actually jump up to D22 because that's the same sort of orientation. That one's fine. And then I'll switch my leads and come back to D21. And that one's fine. And then I'll check D20. And that's a short. We'll try it even in the other direction. And we have continuity in the other direction. And as a diode, that's not supposed to happen. So that's, again, D20. So D20 is shorted. And of course, that is consistent with running the monitor without an isolation transformer. So I went ahead and replaced those diodes in the monitor, or in the chassis. And we've got that actually already reinstalled back in here. If we'll come back like this, I've got everything plugged back in, ready to go. There's a new fuse in there, which is a 2 amp slow blow fuse. We've got the 4 rectifier diodes reinstalled, and I will hook back up the multimeter to test, measure the B+ voltage, because remember last time when we fired this up we had nothing. So there we go. Multimeter is on DC volts, and we'll turn on my TPG and we'll throw the switch on the isolation transformer. 3, 2, 1. We've got HV. Only 123 on the 124. That doesn't seem right. It should be 130, right? I don't know about that. Let's come around to the tube, and we do have an image. Okay. We've got an image here. We change the refresh rate real quick. All right, and I closed one of the garage doors to hopefully minimize the glare. But yeah, we've got an image on this screen. The screen pot is glued, so we're not going to be able really to mess with that. Let me see if I can get the focus dialed in just a tad here. Let's see. Right there, looks pretty good. We'll step through the test patterns. We don't have red, okay? So we've got blue and we've got green. We've got no red. Let me see if I can make an adjustment to bring the red back. All right, I don't know if I touched it or if it popped right back, but we've got our red back. Brightness needs some adjustments. Let me see if I can do that with the black level or contrast on the remote board. There we go. That's not so bad. We've got some issues that might be capacitor related. Whoops. Now we've got a vertical hole. I bumped the cap, or bumped the pot. This contrast pot doesn't want to move. There we go. Ooh, that's not great. All right, so for the most part, I think we've got a working monitor here, so that's not bad. We've got a little bit of work to do. I haven't done a cap kit on this. Let's take a look at the geometry. It's not terrible. So yeah, let me go ahead and go back to the falling block screen, which I like. So this is good. It's working at least now. So let me go ahead, pull that chassis back out of the monitor. I'll install a cap kit. I'll get the hot glue off of the screen pot on the flyback, the screen knob on the flyback. And we'll do that. Like I said, you've seen me do cap kits before. I'll reflow all the usual suspects, the video input headers and the yoke headers and everything. And yeah, we'll do that cap kit. We'll throw this back into the monitor. B plus is 123 on the dot, which is odd, but maybe a cap kit. You know, let's do a cap kit before we do anything further. But yeah, this is progress. I've never seen this monitor work before. All right, the cap kit is complete and we are all reinstalled and ready to test this chassis again on the Wells Gardner 25-inch K7000. Just a couple of interesting things to point out. So this chassis actually has a little vertical daughter board right there. It's a P723. It's not particularly well documented. There's a lot of speculation on the cloud forums and elsewhere on what function that actually performed, but no one's actually sure. So the real issue though is it had an electrolytic cap on it. It was another 10 microfarad bipolar cap. And I don't know if you're going to be able to see it. There's another cap that was hiding behind it, another unusual one called C80. And neither C80 or the C601 that's on that little vertical daughter card, neither of those are included in Peter's normal K7000 kit. I think he actually does have a version of the K7000 cap kit specifically designed for chassis like these that have this vertical daughter board. But that wasn't the cap kit that I was using. So I did have, the one that's in the back is a 100 microfarad, 50 volt, I think, capacitor, C80. And I did have a spare one just in my parts bins that I could throw in there. I did not, however, have an extra bipolar cap. So I actually robbed one out of one of the bipolar caps in another K7000 kit. So I'll just have to remember to replenish that the next time I place an order from Peter at arcadepartsandrepair.com. Other than that, everything went extremely well. So I think we can come back here on the tripod and go ahead with our test. So we're all plugged back in. The chassis is reinstalled. It's plugged into the isolation transformer power supply. I'll turn on the CraftyMech TPG test pattern generator. And we can throw the switch here in 3, 2, 1. I heard the HV come on. Nothing's popping or exploding. All right, we got a little bit of twitchiness. Let me bring you around here to the front of the cabinet. I think this tube might be a little bit tired because it does take a second or two for it to get up and running. Let me change the refresh rate and actually hook up my multimeter to test the B plus voltage. All right, I think I've got a little bit more work left to do on this chassis. The image still isn't quite as crisp as I want. The B plus is a bit low, so this is supposed to be 130, and you know we're barely getting 120 at the B plus voltage. Some of the pots on the remote board have corrosion on them, and they're not. Some of them are just seized up and aren't adjustable at all. So you know, yeah, this thing is working. But first thing I want to do is try to get that B plus up. I'll try swapping in a new voltage regulator. Maybe it needs a new flyback, I'm not sure, but we've still got some work to do on this chassis before it's you know, fully dialed in. Okay, I've been over and over this 25-inch K7000 chassis. kind of to no avail. Again, this thing is working, but the B plus is low and the image is a little bit dim, et cetera, et cetera. I'm having some, image issues. So I've spent a bunch of time with, searching the CLAW forums and going through the flowchart and talking to Mike from Mike's Amateur Arcade Monitor Repair, who's an awesome guy and super patient with all my questions. And yeah, nothing's really doing. There's a bunch of stuff that I tried. So technically, low B plus can be caused by the filter cap. So I went ahead and replaced that, but that didn't work. And then I'm starting to, poke through the power supply or the power, section of the chassis, testing various components. R89 right here is the original. This tested a little bit out of spec, so I replaced that. That didn't work. I even went ahead and swapped the hot, right? All of this, the hot didn't test short or anything, but it could have been, dying a marginal, not hot, voltage regulator. So I swapped out the voltage regulator. That didn't do anything. So I'm kind of at my wit's end. The next thing that I'm really going to do is just really poke around the power section, basically checking every single component and see if I can figure out what's going on. I've checked all the major stuff, nothing doing. And I have isolated it to the power section. So one last thing that I tried that I'll show you right here is what's called the light bulb test. Basically, you are powering up the chassis with the monitor disconnected, the tube disconnected, which is typically quite dangerous, because you're energizing the flyback and the horizontal output section, and that means, the flyback will start arcing. The anode on the flyback will start arcing. So what you do is you remove the hot from the circuit. A couple ways to do that. You can just remove it completely. That's really the safest and most sure way of doing it. But you can also just desolder, and that's what Mike does in his videos. You can desolder the collector pin on the underside of the chassis. Desolder the collector pin of the hot, and really testing with your multimeter to make sure that it is out of circuit and there isn't a solder bridge that's still connecting it, and that's what I've done. And I've never actually shown the light bulb test on camera. I really don't do it that much, honestly. Usually I don't have to resort to this. I'm able to fix monitors. The fixes are usually easier for me. And for the longest time, I couldn't find my 60-watt light bulb, so I had to get a replacement. And all they had were these like fancy old vintage style, if you're looking for incandescent bulbs and you need to use a 60-watt incandescent for this task. The only ones I could find are these old school ones, so thanks Congress for that. So basically we have a 60-watt bulb plugged into a base. I've got a couple of wires just connected to the terminals on the bottom, and then those wires have alligator clips on the end, and one alligator clip goes to the blue wire where we test the B+, and the other one goes to the frame. We still have our multimeter connected, and basically what we're doing here is we are disconnecting the horizontal output section of the chassis, again, by desoldering the collector pin, the collector leg of the hot, or removing it entirely from the circuit. That disables the horizontal output section, disables the flyback, so the flyback doesn't get energized and it's not going to be shooting, electricity out of the, high voltage out of the anode. And we're using this 60-watt bulb to simulate the load of a CRT, of a tube, and we're going to test, check the voltage with that. And what this tells us is if we get the correct voltage that we're expecting, which on a K7000 25-inch is 130 volts, on a 19-inch it's 123. If we get the correct voltage with the light bulb test, that tells us that we've got a problem in the horizontal output section. Maybe it's a bad flyback, something else. But if we still get low voltage with the light bulb test, that tells us our problem is somewhere in the power section. So why don't we go ahead and do that? I've got my multimeter set to DC volts. Let me prop it up on its little kickstand so you can see it a bit better. Okay, and we are expecting 130 volts, maybe a tiny bit less because 60 watts isn't quite the load of a CRT. But yeah, I've got it all powered up, all connected to my isolation transformer power supply like I would normally have. We're going to hopefully see the light bulb turn on, and we want to see 130 volts, but I can tell you now it's not going to happen. 3, 2, 1. There we go. The light bulb is on, as you can see, and we're around 115 volts, which is still low. So there is something in the power section of this chassis that's bringing that B plus voltage down. You know, even at 116, that's still low. And the fact that it's fluctuating a little bit, I don't like that either. So yeah, so I've got some work to do. I'll be poking around, you know, seeing if I can find something else in this power section that's not correct. The linearity coil, the glue broke on the cap, and the cap piece comes right off and it snaps back on because it's magnetic. Mike said that was normal though, so not to worry about that. But yeah, B plus is still low even in the light bulb test, so I'll go ahead and turn it off. So yeah, not going to be fully fixing this chassis in this episode. So call it 2.5 out of 3, because we brought this back from the dead, but it's still not working fully completely. But there's still one more thing that I want to try before calling this an episode. So let me go ahead and set up for that. All right, what was it that Yoda once said? There is another chassis. Sorry, terrible Yoda impression. But I've got one more K7000 chassis that I want to try. This is also a 25-inch. I think I mentioned that one of those 19-inch monitors that I was working on earlier in the episode is intended for my buddy and Overtime Arcade channel member, Jerry Voluptuous. Jerry's an awesome guy. We got a trade going on, and one of the things, you know, he's getting that 27-inch or that 19-inch you know, working K7000 monitor, and I also promised him as part of this trade a 25-inch chassis, a 25-inch K7000 chassis. I didn't make any guarantees about the condition of it, but I went through my parts pile, my parts chassis, and this is the nicest one that I've got in there that's remaining. It's complete. It actually has had a cap kit installed, although they did not replace the little C203 ceramic capacitor or whatever on the neck board. This thing has a little another daughter card right here, but instead of a vertical one on the chassis itself, it's mounted on here, sort of above the flyback, and it says P609. They even you know, replaced the caps on this thing, and they're all Nichicon caps. So this thing has been worked on. It has a fuse that's intact, and I just got this as part of a parts lot, so I have no idea if this thing works or if it's got any kind of issues. But I've got it plugged back into this 25-inch monitor, and we're going to fire it up and give it a shot. So we turn on the Crafty Mech Test Pattern Generator TPG. And here we go, throwing the switch. 3, 2, 1. Nothing. Nothing. Oh, we got something. Oh, wow, we do actually have an image. Let me get the tripod set up and see if I can lock that image in. All right, well, I got the image stabilized, but it's not quite perfect. I'm having some issues. I don't know if it's coming up on camera. There are some, like, they almost look like fat scan lines horizontally through the image. Not exactly sure what causes that. As you can see, our B plus is a bit low, around 120, so having a similar issue from the same monitor. Maybe I'm wondering if maybe this isolation transformer I have just isn't beefy enough to power a 25-inch tube, although I think it is. It does look like it has the correct 130 volt voltage regulator installed, but who knows if that's, you know, going bad. So we're kind of in a similar situation here. A couple of other issues. This image is way too tall, and this is with the vertical size pot, you know, cranked to the minimum, so that's as low as we can get it. So, you know, some things we could do to fix that, you know, similar to issues we've had with other monitors. But all the colors are here. We can step through the test patterns, and I don't know, maybe those lines are showing up a little bit better. Here, we've got all of our colors. We have a bit of a Diodes issue going on here. One of the reasons why, you know, when I said, oh, nothing, is I didn't hear the HV come on. I didn't hear the Diodes circuit activate. So maybe the Diodes circuit is shorted or something. I don't know. But yeah, there we have it. Got all of our patterns here. And we can get to there's our cross hatch, and you can see we've got some geometry issues. And like I said, this is going off the screen too tall. But hey, Jerry, it's a working chassis at least. And maybe if I have time, I'll try to poke around with this one too. Or perhaps you'll have better luck with your tube and you know, your power supply setup. And you can see some of the retrace lines are even showing up here. So yeah, it's working, but not working correctly. And yeah, so what is that? You know, 2 fully working 19-inch monitors in this episode and 2 partially working 25-inch monitors in this episode. Does that make, you know, 2 full and 2 halves is 3 out of 4, so we're batting 750, but yeah, hopefully Jerry will be able to, you know, get this fully working, or I might be able to, because, you know, he's a great guy, great supporter of the channel, and I want to take care of him. So yeah, he's got a great trade deal for me going on. But I think we'll wrap up the video here. This has been a super long one. If you've never subscribed, please consider doing so. You want to make sure you don't miss any of these awesome episodes. I release new episodes every weekend. Every once in a while I'll throw a bonus one in, like the one that I did for the Children's Miracle Network deal going on with Ace Hardware that nobody watched. Maybe they just scrolled past it thinking it was an ad. So I got to come up with some better thumbnails. But if you like this episode, click that like button. It tells YouTube to recommend this video to people like you. If you really like what we're doing, click on the join button down below to learn more about what it means to become an Overtime Arcade channel member, just like Jerry. Jerry's a huge benefactor of the channel. You get access to some awesome perks. You get to support the channel, that sort of thing. You can always leave a super thanks or a super sticker. People have been doing super stickers. Yeah, and if you've ever run into issues like these with any of your monitors that you've worked on, issues that I've had here, you know, please give me a comment down below and see if, you know, let me know if you have any pointers. But I'm tired. I got a lot of raw footage to edit, so I think I'll wrap it up here. As always, thanks for watching Overtime Arcade. I'm Charlie, and I'll see you next time.
Overtime!